So that's how you provide the confidentiality. So now next question is how do we actually provide the integrity of the data. So how to provide the integrity of the data is the second part of the question. But before that, let's understand how exactly integrity can be compromised. As I said in the beginning, there are natural phenomena. Such natural phenomena will also sometimes contribute to the compromise in the integrity. So here are two such examples. So let's say I have a database and I have stored this data. What is this data? 01010 in some either in a file or in a database, in a table, and something happens to the disk. So disk is an electromagnetic device. Sometimes by external interference, some of the bits might get flipped, and then the data might be one of the bit. If it flips the third zero, which is here, if it to one, then you end up with something else on the disk. Nobody actually came and tampered with the data, but the very nature in which that device operates itself contributed to such changes. So these do happen, although they might be very rare, but in general such changes are possible in the storage device also. So this is one way with which the integrity of the integrity of the data can be compromised. So the second thing is, if I transmit the data over the network. So here in this case, let's say the 10 say 10101, this sequence is transmitted over the network, and by some external interference within the network, when the data is on transit, if some of the bits get clipped, so you might receive something else which you did not send in the first place. So the received data might look something else. Then this is called an erroneous receive. Then how do we actually detect that? So since I transmitted something and I received something else, there is a compromise in the integrity. Something happened in the middle. Although this is a natural phenomenon, but still the integrity of the data is compromised. So we do want to have protection against such natural changes, either in storage or in during the transmission, or an adversary sitting in the middle, which the refer to the diagram that I showed in the beginning. Somebody sitting in the middle and then manipulating the data and sending it to the recipient. So such kind of alterations also, against that also, they also compromise the integrity. So we want to have protection against them. So as I said, hardware bit flips are one way to with which the integrity of the data is compromised. And someone sitting in the middle and rewriting the data, having access to the resources, then manipulating that can also contribute to the compromise in the integrity. We want to have protection against them. So next question is, how do we actually understood the integrity is compromised either by natural phenomenon or by some malicious user sitting having either access or sitting in the middle of the transmission. So how do we actually protect them? So in some sense, the techniques that we saw for protecting the confidentiality in the previous case, by encrypting the data or by having the right access control mechanisms, those techniques will also help to prevent integrity compromises. So if I have the right access control, it is supposed to block the unauthorized access to the resources, the data. So if that is then the chances that that adversary or malicious user doing the changes in the data itself is minimized. So in that sense, the mechanisms for confidential protection will also help to achieve the integrity of the data. In addition to that, in addition to those techniques which helps us to provide the confidentiality, something else can also be taken, which are these. I can take the first thing is I can take the periodic backup of the data. So I have a primary copy, let's say maybe let me call it as F, and a backup copy of that one is also taken. Maybe let's call it this as F at. So f hat is a backup copy. If f is compromised, what I can do, I can take f hat and then restore that data. That is possible. So in that case, taking the backup of the data periodically helps. So if I come to know that integrity is compromised, the file is changed, then I can actually detect that and then restore the data. In that sense, the taking backup helps. The second technique that you can employ is calculating something called as the checksum. So checksum is a mechanism. So you can understand this in this way. So I have some data. Let's maybe the ABC is my data. I supply this to a function. So let's call that function maybe as H. So by taking ABC as input from the file F, it generates some piece of output. So maybe one HY is the output that it generates. So this is called as something happens, magic happens inside this function. It generates its output. This is called as the checksum. So how does the checksum help? So this is if there is any change in this data, let's say ABC becomes the C is turned into a D. When I supply this data, the tampered data, so I will not be able to regenerate this one H by whatever is there. So by doing that, I can actually detect the alterations in the input. I know that the checksum value earlier was 1HY, but since the content of the file is changed from ABC to the ABD, so and then the instead of 1HY, it's the checksum value might now could maybe 2YZ, something like this. So in that case, so this is not same as the previous one, so I'll be able to detect the changes that has happened either in the storage or during the transmission. So such functions are available. So the checksum calculation methods are available. So those techniques also we can make use of. And the third method is something called error detection and the correction codes. So you anticipate it. Remember in the previous slide we saw, when I transmit the data, sometimes the bit without any adversary sitting in the middle, also by natural phenomenon, such changes do happen in the network. So in order to, these are unavoidable. So I anticipate such changes do happen in the network. What I do is I put some kind of the error correction mechanism. These error correction mechanisms carry additional bits during the transmission. So I want to transmit maybe 3 bits of the data, but I put additional 2 bits of the data and then transmit total 5 bits. So these 2 additional bits help me to recover the data at the other end, at the recipient. So such error correction code techniques are available. So particularly if you go for wireless medium, the chances of such changes, errors getting introduced during the transmission is very high. So I can use such robust error correction code methods to protect the integrity of the data during the transmission. So sometimes it is not good enough to take the backup of the data and provide the checksum and all about that, but also the something called as the metadata, protecting the metadata is also important. So what are the metadata? Metadata includes the who is the owner of the file, what is the size on the disk, what is the last time the some user has either read the content or written the content to that particular file, and if there is a remotely accessed from which geographic location or which IP address this file has been accessed. So knowing such details will also help in protecting the data, or else if it is compromised, then who actually did that in post-mortem analysis, such thing will help. So if let's say why this is important. So let's say if I am the attacker, and if I want to gain illegitimate access, I gain access to some remote computer, I change a file, and I know that such metadata is also written. So when I change the file, it will also store I did change this file at so and so time. So such it will leave my trace on the target system, on the target computer. I want to erase that as well. So say what I can do, if I am an attacker, I might want to go and erase that data also. Some log information that is put on the file on the computer, I want to erase that as well. So in order to avoid such situations, so if you want to have such trace mechanisms in place, you also need to protect the metadata of the resources or the we looked into the confidentiality and the integrity, and the third aspect is the availability. As I said, availability refers to the timely availability of the information or the resources to the right set of people, and particularly some piece of information. So, for example, the banking transactions and the quotations of the stocks, these stock codes are real-time value. So if there is a delay in some milliseconds or microseconds, then the stock price might change. So in that situation, or in general, any data that is stored, if as long as I am the legitimate user, if I am able to access it, it's fine. If I am not able to access it, then I don't know what exactly happened to the data. So if the information is not available, then the other two aspects of the security, what are those? The confidentiality and the integrity. I'm not sure about those things as well. So in that sense, availability of the data is very important. All the data which should be accessible to the legitimate users. So then the question is, how do we actually make the things available, the right information to the right set of people? So one is the thing is, you can have kind of physical protection. So as I said, the servers or the computers on which the data itself is stored, if somebody has got physical access to that computer, then the availability might be in danger. We do want to avoid such situations. Or by natural phenomenon, some fire erupts in the room in which the computer is stored. So such situation can also happen, natural. So we do want to have protection mechanisms against such natural as well, so that the information is available. So what you can do, you can take the backup of the data, particularly if let's say the banking transaction details are stored in the server. So if a physical damage happened to the building on which the servers are stored, then if the servers in the process are also damaged, you lose the complete data. So in that case, what you can do, you can take the backup of the data. Not necessarily this backup is stored in the same place as the server, the primary servers are stored, but in a remote place. And you try to synchronize the data from primary to remote place. Maybe let's say if the banking server, the primary server is in Mumbai, I might have a backup in the Chennai. And these two servers, the primary and the backup, are synchronizing on regular basis. The other thing that I can do is to build some kind of fault tolerant systems, like the RAID disks. So if one disk fails, the other disk can come up, and then the operations can continue. So such kind of the mechanisms I can have, and then make sure that this will help that the information or the data is available to the right set of people at the right time. So, so far what we understood is the confidentiality, integrity, and availability are three pillars of the information security or the security. We do want to have these things in place. There are a bunch of techniques that help us to maintain the confidentiality and integrity, and also the availability, both technical and non-technical means. And then if I have those many techniques, so if I want to have some kind of the protection, every security mechanism with the, for example, the confidentiality, if I want to encrypt the data, if I want to have build redundant system, fault tolerant system, they come with some cost, because I want to have, remember that example, if the primary server is in Mumbai and the backup is in Chennai, I need to have two servers. So this comes with the cost. In fact, every security, every protection mechanism that you can think of, all of them come with some sort of the cost. So you need to make some kind of investment. So in that case, can I make an informed decision? So what kind of the data I am protecting, I am trying to protect, and what kind of the security mechanism that I want to have. So how much cost that involves? Is it worth employing such kind of the security mechanism for protecting this data? So in simple terms, this is called return on investment. To protect some data which is worth of 10 rupees, I should not be investing 100 rupees. So that is simply not worth. So in that case, to make an informed decision, you can need to ask some questions. What are the questions? So if I lose some data I have, if I lose the data, what is the financial implication that I am going to have? So if the data going to the wrong hands, how much loss that I am probably likely to incur? So if I have the knowledge of this, then I'll be able to make a decision. It's a good decision to employ what kind of the security mechanism that I should put in place. And if the data that is getting compromised, if the confidentiality of the data is compromised, then what is the danger? How much going to the, if let's say if I store some data, maybe a photograph, my personal photograph stored on the computer, and the other thing is some kind of the core business, the confidential value of a company. These two have a different kind of the implications. So the trade secret of a company going to the wrong hands, or some personal data stored in a personal computer going to the wrong hands, may have different implications. So in that case, you need to ask this question: if this data is compromised, what is the implication of that data? And the third question that you want to ask is, if my system is under threat, under the attack, and if my system is is down, and if my server is down, then what is the implication of that? So think of this situation. So if I want to access some website, maybe railway booking website or things, so if every time I try to log in or book a ticket, if the server is not accessible, I as a user would be frustrated. And it also has an implication on the reputation. So the company is involved. So every time if the legitimate user trying to access, if it is not available, then it does not carry a good image. So, and the next question is, if I want to have those three things: confidentiality, integrity, and availability, and I assuming I make some choices of these are the kind of security mechanisms that I want to have, and then those security mechanisms, in addition to the cost of procuring them or installing them, there might be a requirement for staff to manage those systems. So these staffs also you need to pay them. So how much cost is involved in paying these staff members who maintain those security systems is also another question. So over the long period of time, if large number of the staffs are required or highly skilled manpower is required who are paid a large sum of the money, then that has implications on your runtime or during the maintenance time. So we need to be aware of this as well. And then again, the reputation and damage and financial implications. This is related to the first 3 points: the downtime, the confidentiality loss, and in every time there is a loss in the data or confidentiality, your reputation is also at stake. So you need to worry about the reputation of the organization which is involved. So if I am aware of all these things, then I can make the right decisions of what kind of the security mechanisms I should be putting in place, so that the confidentiality, integrity and availability of the data is maintained. So now, we understood that confidential, integrity, availability is important, and second thing, there are some mechanisms with which you can achieve these things. And then we asked what kind of the costs are involved. We asked some questions so that we can make informed decisions. So now, if I am a designer of a security system, how do I actually go about designing such secure systems? So that is the next question that we ask. There are some principles which actually help us to design the security systems. These are called golden principles of designing the security systems. These are not from the end user's perspective, but the designers who develop the secure applications, for them these are applicable. What are those? The first rule says economy of mechanism. So meaning that any design choice. So if I am, let's say, developing a encryption algorithm and some application, so that encryption algorithm, the usability of that algorithm should be very intuitive. The more simpler the design is, the better it is for the end user. So if you think of this situation, if a large number of configurations are required, let's say the system to use the 100 parameters need to be configured, then larger the number of configuration need to make, then the larger the chance that the end user does not do that job perfectly. Even if one configuration parameter is actually not done well, then that might have implication on the security of the system. So in that case, having the security system which is actually simpler in design by fundamental principles is very helpful. And the second golden rule is, when I design a secure system, the default configuration should be very conservative. So meaning, so think of this. If all of us have used web browsers normally have this configuration. So which is that strict security, medium security or low security. And then by default it might be linking you to the strict security, where by default the tracking a user is disabled, or some malicious application which you download from the web is actually by default quarantined, it's not allowed to log in. Such whatever configuration, when I start to use a system, the default configuration should be very conservative. It should give very minimal amount of access to the system. So by having such safe mechanism configurations, we can actually protect the security of the system or the resource. And the third principle says complete mediation, meaning any security mechanism, assuming I have one security mechanism which is in place, which is in charge of protecting the system, that system should be completely in charge of mediating the user, act as a mediator between the user and the system. So if the user action is legitimate, and if he is not doing anything which is beyond its permitted or access level, then only we should provide the access to the user or permit the user to do that action. So that system which is in charge of the security should be mediating this and control that action. And the fourth golden principle says the security system that I am designing should by nature should be open. Anything that is open, anything which is made public, receives the public scrutiny over a period of time. Many people might scrutinize that application or the system, and then it matures, and it will also help you to identify the bugs and also fix it. So keeping the algorithm or mechanism secret itself is not the best way to design the mechanism. So in that case, open design is helpful to achieve the confidentiality, integrity, and the availability. And the fifth golden rule says separation of the privileges should be there. If multiple users are there accessing the system, these one user to another user, if their role changes, these separation should be well defined. Who is allowed to access what, that should be very well defined in the system. And the next golden rule says any application, the application that is running on the system should have the least privilege or the bare minimum privileges which is just sufficient to accomplish or do that job. So let's say I develop an application which does not require a root access. In that case, running that or providing the access to the root access to that application does not make good sense. So we should be at the time of designing itself, I should be deciding what is the application that I am designing and what kind of the access or privileges that application requires. You just provide that bare minimum amount of the access to that application or the process or the program so that it runs and it does its job. And if the application is used by multiple users, then the sharing among the between the users should also be at a minimum, which is just sufficient to do the operation. So for example, if you go back to the railway ticket booking example that I told in the previous case, so if I am the user, if somebody else X is also the user, there is no reason why I should be accessing person X tickets booking. So in that case, although I and X might be using the same system, the among between two users, the sharing is Excel should not be there. The data, the reservation data, and other details should not be said. But there are some information which is common to maybe I I and person X might be looking for a booking on the same train, then the availability of the seats on that seat may be shared between given to me and him as well. So when I do the booking, so or the person X does the booking, then the updated information should be coming to me. So one seat less than when the ticket is booked, the automatically the system should deduct one seat and then it should show the updated number of the seats to either me or to the person X. And the next golden rule of secure system design is it says that the psychological acceptability should be there. Meaning, if I design a system and the user interface that is there, by principle should be very intuitive to use. So the user should not be thrown with too much of information on the screen, or he should not be asked to configure too many things, select too many things. Those are all very bad choices. So the minimal amount of the information that you show and looking at the interface, what action the user should take, that should be intuitive. So not all users are tech savvy, even users who are common users who are not engineers, doctors will also be, if they are trying to access your system or access your application, for them also it should be accessible in an intuitive fashion. These are all the golden principles. Even if you follow all of these golden principles and design secure systems, then also sometimes your system might be compromised. If assuming such compromises are there, if you are a system administrator who is in charge of protecting those systems, then as a post-mortem analysis, you must have some data or some way to look into the what exactly happened to your system, who logged in, what time, when, from where. So such information be there. So if in order to have such information, so you should have a mechanism for something called as compromise recording. These keeping the log information in the system is also required. So that is also part of the secure system design. Any system which is actually secure and should also have this compromise recording also in place, so that the post-mortem analysis can be taken done. So we can establish the truth of who exactly did the changes and why and when. Such question can be answered. Even in some cases, if this evidence can be taken to the court, and then the culprits can be prosecuted. So having this information and preserving this information without manipulation, this is also an important aspect of the secure system design. So in a nutshell, if you follow all these golden principles, then you will be able to design a system which is secure.